So welcome back. In today's class, we'll explore the fundamental principles of quantum mechanics. Okay. So these are four magic ideas that explain why the tiny world of atoms and electrons behaves so differently from normal, or let us say everyday world. Okay. So let's begin the journey from simple concepts of to fascinating quantum behavior. Okay. So this is the overview that I am going to discuss in this today's class. Okay. So quantum mechanics may sound, as you people know, aware of that, it may sound complicated, but it's built on different uh, on just four simple powerful pillars. So one is nothing but superposition, and the second one is nothing but uncertainty principle, and the third one is nothing but entanglement, and the fourth one is nothing but wave particle duality. So think of them as four stories and reveal how nature hides it secrets at atomic level. But by the end of this lesson, you will see how these ideas connect to real world technology like quantum computers and quantum teleportation. In further classes, I want to discuss about quantum teleportation and as well as what is quantum communication. Let's see in future. Okay. So moving on to the concept of superposition. Okay. So let's start. In classical life, an object can be only in one state at a time. So simply think about a switch. So that can be either on or off. But a quantum particle can be in both state at the same time. That you need to remember what I said. Both states at one time. So mathematically, this is how we can represent a single qubit. Okay. So this is the formula. Alpha ket psi is equal to alpha ket 0 plus beta ket 1. So this symbol we call it as ket, and this symbol we call it as bra. Okay, that you need to remember. So we'll be having only two bases. So one base is ket 0 and another base is ket 1. So this you need to remember. Okay, and here alpha and beta are nothing but probability amplitudes. Okay, so uh, this says that this alpha and beta says that the chance of finding particle 0 and 1. So you need to remember this particular terminology, probability amplitudes, and you should also remember that mod alpha square plus beta square should be equal to 1. This we call it as normalized condition, or we can simply say normalization. Okay, that you need to remember, normalization. I couldn't write here, but please make a note of that. Okay, normalization. uh, I am writing here normalized. I am writing, if the condition satisfied, get alpha square plus beta square, then it is called normalized condition. Okay, so moving on to how this particular equation has been arrived. So let us start with ket 0. Actually this is one typical error, that is nothing but, let us start with ket 0. Okay, so this means the qubit is at only ket 0. Okay, and apply Hadamard gate. So h of ket 1 or h of ket 0. Okay, in this particular scenario we will be using h of ket 0. So h of ket 0 is nothing but it creates this. So you should be familiar with the matrix representations of all those gates, then only you will be able to solve this particular equation. If not, I will explain in the next video logical gates versus quantum gates. Okay, so now if you look at here, so these I can simply say as 1 by root 2 ket 0 plus 1 by root 2 ket 1. So this is combinedly have been written as 1 by root 2 ket of ket 0 plus ket 1. But if you define it, 1 by root 2 ket 0 plus 1 by root 2 ket 1 will be your output. So if you want to check the probability of 0, then you need to, this is nothing but, this looks like, if you remember this formula, this looks like alpha, and one more root 2 will be the here, and this looks like beta. So alpha is nothing but 1 by root 2, okay, and beta is also 1 by root 2. If you take the square, mod square, then you will be end up getting 1 by 2 in both cases, okay. So in both cases you will be getting 1 by 2, so that is why I have been written here. So 50% chance to get 0 and 50% chance to get 1. So there is an equal probability to get 1. So these we call it as superposition, okay. And you need to remember, I have given one more statement here. After measurement, the wave function collapsed into single state, okay. Either it will be 1, either it will be 0. That is how superposition works. So moving on to another concept called entanglement. Now this is the main concept, okay. This entanglement, superposition, and no cloning theorem, this works in every concept that you need to remember, okay. So now comes entanglement. So this is the most mysterious quantum effect. So let us talk, suppose we are having two qubits, okay, and they can become linked so deeply that they behave like one combined system, okay. So they are linked, that is nothing but we call it as, and they are entangled, okay. If they are entangled, okay, if we change or measure one qubit, okay, think of this is first qubit and this is second qubit, again this is first qubit and this is second qubit. So if they are entangled, if I measure the first qubit as 0 and second qubit will be obviously 0. If I measure first qubit as 1, second qubit will be obviously 1. That is what entanglement says. There will be no physical connection between particle A and particle B, but if I measure one particle, okay, then I can know the exact state of another particle. So this is how entanglement works, okay. So these are used in quantum communication as well as in quantum teleportation. So moving on to one circuit, okay. So initially each qubit is started with ket 0 and ket 0, okay, that you need to remember. So please look, I am applying ket 0 with Hadamard gate. Just in the above slide I have discussed, if it is h of ket 0, then the formula is nothing but 1 by root 2 ket 0 plus 1 by root 2 ket 1. So that you need to remember, okay. So if it is, for example, if it is in the other case, if it is ket 1, so the formula will be like 1 by root 2 ket 0, minus will be indicated in between, okay. Minus 1 by root 2 ket 1 will be your final output. So what is this? Are you familiar? So this is nothing but we call it as C naught, okay. What is this? C naught. So I am not able to write on this pen as of now. So this is nothing but we call it as control, okay. What is this? Control. And this is nothing but we call it as target, okay, that you need to remember. Target, okay. So now look what this circuit mean. Ket 0 combinedly, initially it is like, before going on to the calculation, please I will explain here itself. So initially if you combine it, you will be getting ket 0. This is nothing but 1 qubit 1 and qubit 2. So after that, moving on to one more step forward, okay, then please look, we are applying Hadamard gate, this H represents Hadamard gate, to first qubit. So already we know h of ket 0 is nothing but 1 by root 2 ket 0 plus 1 by root 2 ket 1. So next after that, so control is at qubit 1 and target is at qubit 2. So if control is 0, target won't flip. If control is 1, target flips. That you need to remember, that I have explained here. Okay, so initially we started with get 0 0, and then I applied Hadamard gate, so it becomes 1 by root 2 ket 0 plus 1 by root 2 ket 1. So if you apply C naught on this particular equation, you will be ended up getting this result. Okay, okay, but from here the qubit will change as 1 1. Okay, if you apply C naught on this, you will be end up getting 1 1. That is the final equation, I think. Yes, so after applying C naught, control first, target second in that particular circuit. So C naught flips the second qubit only if the so if target is, if control is 1, target flips. So this is flipping. So from here it is 0, here it became 1 because control is at 1. So here now no change, nothing will be happening because control is 0 and target is same as it is. Okay, that you need to remember. So now look here what I have given. Now both qubits are entangled. If one is measured as 0, then the other will be also 0. So if one is measured as 1, then the other will be also 1. That you need to remember. So so these two qubits are now perfectly correlated. So this we call it as Bell state. Okay, that you need to write in the examination. Okay, so moving on to the most important topic, that is nothing but Heisenberg's uncertainty principle. So this is proposed by Werner Heisenberg. Okay, so it says we can never know both where a particle is and how fast it is moving at the same time. Again I am repeating the definition. It says that we can never know both where a particle is and how fast particle is moving at the same time. So let us talk about a simple scenario. I will explain in very easy way. So let us talk about one example. So I have a butterfly, I leave it from my hand. Okay, I left it from my hand, just think of. So what happens if I leave that butterfly from my hand? It may go anywhere, it may go with any speed. So can I get exactly where it can go, or can I get exactly what time it can reach to for some target? No, right? So same way uncertainty principle says, okay, we cannot know exactly where the particle is and how fast particle is moving. So this is the equation: delta x into delta p is less than or equal to h by 4 pi, and delta x is nothing but change in momentum and delta p is nothing but change in position. So h is nothing but Planck's constant. Okay, that you need to write. Okay, Planck's constant. So I am not able to write here. So Planck constant. So this is what about uncertainty principle. And moving on to the last topic, so wave particle duality. So wave particle duality, so the name itself suggests something in our imagination. Wave particle duality. So dual role. So if a particle is having two characteristics that are nothing but it can have as waves, it can travel as particles, then we call it as wave particle duality. So one example I can say light. So light and matter sometimes behave like waves and sometimes behave like particles. For example, and I haven't included the double slit experiment. So what does double slit experiment says is nothing but we'll be having two slits. Okay, two slits, and I will send my light through both the slits, and inside that particular slit you will be they will be forming one interference pattern. So two or more waves collidely travel, we call it as interference. Okay, so this is what interference says: two or more waves collidely so travel. So unless you see it, it will, the light inside this double slit experiment travels in interference pattern. If someone wants to eye on it, let us stop. If I want to eye on it, then the particle looks like traveling like this. Okay, it won't be interfered, it won't look like interference. Okay, so the formula that is given for this particular thing is nothing but lambda is equal to h by p. Okay, that you need to remember. And thank you guys. So if any doubts, let me know in the comment section.